Okay guys, so like I said, we're working with U substitutions today. This is a method that we can use to integrate a very complicated function. Now, in order to use a U substitution, we have to have multiplication. All right, so we have to start with two functions. Now, one of these is going to be a composition of functions. What I mean by a composition of functions is we have some function inside of parentheses. It might be getting squared. We might be taking the square root. We might be cubing it. All of those things can happen to it. So one of our products, or one of our factors rather, of the product is just going to be a regular factor, but the other one's going to be a composition of functions. So we're going to choose U so that du is similar to the other part of the expression. So like when we choose our u, the derivative of it is going to be very similar to the other part. And the u that we choose is normally going to be the inner part of a composition of functions. So what we mean by this is that it's going to be what's inside parentheses. That's what we're going to let u equal, whatever's inside the parentheses. Then we're going to compute du. What do you think du probably means? Derivative of u. So we're going to find the derivative of u. Then we're going to rewrite the integral using the u and the du. So what we're trying to do here is get rid of all the x's. Then we're going to integrate in terms of u, and then finally replace our u with our x's. Okay? Now that's not going to make a lot of sense yet, but as we go through it and you refer back, it will make more sense. Okay, so looking at our first problem, this is similar to our warm-up problem. But on the warm-ups, we had x to the second minus 1 that we had to square. That's pretty easy to do. But if I asked you to multiply out x to the fourth minus 1 quantity to the fifth, horrible, right? You'd have to use Pascal's triangle, binomial expansion, all this stuff just to even get it into the right form. So that's what's so great about a u substitution. I'm going to let u equal the inside part of the parentheses. See how that's what we said we're going to let u equal? So u is going to equal x to the fourth minus 1. It's only the inside part of the parentheses. Now we take the derivative. Olivia, what's the derivative of that?
4x.
And now we're going to put dx after it. Anytime we take the derivative with respect to x on these, we're going to put dx to show that's what we took the derivative with respect to. Now we're going to look back at our original problem. X to the fourth minus 1 is right here. What is that the same thing as? It's just u, isn't it? That's u. So rewriting the problem, this box, x to the fourth minus 1, is u. What's happening to u? It's raised to the fifth power. Now look at the rest of the problem. 4x cubed dx. What's another name for that? 4x cubed dx. What did we just say is another name for it? du. So all of this in circles gets replaced with du. What should happen if we've done this correctly is we should have a complicated problem that now is an easy problem. This is pretty easy to integrate, isn't it? What's the integral of u to the fifth? The integral, not the derivative, the integral. Right, 1/6 u to the sixth plus c. But here's the thing, in this very last step, it says replace u with g of x. So that just means write it in terms of x now. So it's going to be 1/6. I look back at what u was in terms of x, and it was x to the fourth minus 1. That's what u was, to the sixth power plus c. U substitutions are great because not only do they take this complicated problem and make it doable, they also give us the answer in completely factored form. which is really nice as well. So this is a very valuable method for integrating when we can't do it any other way. Number 2, we look at it and we say, is it just a straight integral? It's not, because it's a product. We don't have a product rule for integration. We do with differentiation, but not integration. So that means we're going to try a u substitution. So thinking of this, I could also think of this as the integral of 8x times 1 plus 2x squared to what power? 1/2. Now, 99% of the time, u is whatever's inside of parentheses. So what are we going to let u equal then? Right, so u is going to be 1 plus 2x squared. And now we have to take the derivative of that. Gage, what's the derivative of that?
4x.
And then what did I say to put after it?
Dx.
Dx. All right, so now we look back at our problem. 1 plus 2x squared. Well, all of this right here, that's going to be u. Now, I want this to be equal to the rest of the problem. But the rest of the problem is 8x dx instead of 4x dx. Well, how can I make this be 8x dx like I want it to be? If I multiply this side by 2, I must also multiply this side by 2. So 2 du is going to be equal to 8x dx. So now what is this 8x dx in the box? What's it going to get replaced with? 2 du. So now my problem is going to become the integral of, and I always like to bring any constants out in front. So these boxes gets replaced with 2 du. What's this right here? So it's u to the 1/2. So what should happen is we took a very difficult problem. Now it's a pretty easy problem. We should not have u's and x's. If we have u's and x's, we messed up somewhere. We have to have all the same variable, which we do. So now we've got 2. We're going to add 1. We're going to multiply by that reciprocal plus c. And now we just have to plug back in for our u. So 2 times 2/3 is 4/3. We look at what u was. And that's going to be the integral. So that very complicated integral turned into a pretty easy problem after the u sub. All right, looking at number 3. Look at what we have to have in order to do the u subs. We have to have h of x times f of g of x times. Do we have times here? Do we have multiplication? No. We have to rewrite this as multiplication. So it's going to be 3x times 1 minus x squared to the what? -4. Now we have to decide what should u be equal to. Will, what should u be equal to?
1 minus x squared.
So u is going to equal 1 minus x squared. I'm going to take the derivative. The derivative of u is du. The derivative of 1 minus x squared is -2x dx. So looking at the problem, 1 minus x squared, that's right here. That's going to be our u. The rest of the problem must get replaced with something in terms of du. But I have a 3x dx instead of a -2x dx. What do I have to multiply this by to get the 3x dx that's necessary? Say it again. Yeah, but I'm not sure everybody would understand why that would work. Would you guys understand how multiplying by negative 1.5 would give us 3x dx? Yeah, so we need to get rid of the 2 and get a 3, right? So to get rid of the negative 2, I have to multiply by something over 2 to get the 2's to cancel. I want to get a 3. So that's what I have to multiply by, is negative 1.5, which is negative 3 halves. It's a little easier to see why when we write it this way. So now we're going to look and we see, okay, we have a negative 2 and a negative 2. Those are going to cancel out. Can you see how now I've got the 3x dx that we needed? So here's the 3x dx in the box. So everything in that box is going to get replaced with a negative 3 halves du. And I always want to leave room in here for whatever u is. So here's my u in the circle. And what's that getting raised to? Negative 4. Now just carry down this negative 3 halves. Oops, not 3/5, 3 halves. And now I'm going to have to add 1 in order to integrate. So what do we get if we add 1? So we're going to have u to the negative 3, but then what do I also have to do when I integrate? Divide by negative 3. All right, so what does all of that turn into? Well, the negative 3's are going to cancel, so I'm going to have 1 over 2 u to the third plus c. You see that? How the 2 goes on bottom, the u to the negative 3 goes on bottom to make it positive. Now, here's what's so kind of sad. Like, people go through all that and then they put this as the answer. Is this the answer? No, because our answer has to be in terms of x. So you got to go back up and see what was u. It was 1 minus x squared. So it's going to be 1 over 2, 1 minus x squared gets cubed plus c. And that would be our final integral, completely factored, everything done to it. All right. What about number 4? What is u going to equal here? Right? So u is going to be 1 plus 3 over x. Now when I go to take that derivative, though, I don't really know how to take the derivative when it's like that. This was from our warm-ups. What's another way to write this so that we can take the derivative? All right, everybody see why that would be equivalent? So now I'm going to take that derivative. Megan, what's that derivative? Good. It's negative 3 over x squared. Just to help people understand, negative 3x to the negative 2 to start with, and then negative 3 over x squared is right. And I want to put dx after it. Show I took the derivative with respect to x. Now look what I want to get, though. See, here's our u. That's u. It's getting raised to the 4th. But all of this has to get replaced as well. So I have a negative 3 over x squared dx, and I want to get a 1 over x squared dx. What am I going to have to do to both sides then? Multiply by negative 1/3. Great. So these would now cancel out, and I would get that 1 over x squared dx that I wanted. So everything in this box, right here, that's going to get replaced with a negative 1/3. Here's my u to the 4th. This is all just du. So now this very complicated problem is this easy problem to integrate. See, here's where it gets confusing too, because we're taking derivatives and we're integrating in the same problem, and that can get a little tedious. But if I integrate this, what do I do? Add 1 or subtract 1? Add 1. So it's going to be u to the 5th over 5 times negative 1/3. So that's going to be negative 1/15 u to the 5th plus c. And then just replacing it, it's going to be negative 1/15 u, look back at what u was, that would be our answer. Okay, not too bad, right? So you've got problems to do for your homework. It's on page 297. The problems, you're going to have about 3 or 4 that are really easy, like our first problem, where that du just matches exactly. Those are the easiest kind of problems. Then you'll get into some where that du is not going to match exactly, and you have to think, what do you need to do? Sometimes we multiply to make it work. Other times we had to divide. Well, not there, actually, multiply there. We actually always made it multiplication because this is truly dividing, right? When we multiply by negative 1/3, that's dividing by negative 3. Okay? All right, good job with that.